Let's identify the image of the point 5, -1 under the rotation of theta equal to 30 degrees about the origin. The idea of about the origin is very important because we're going to rotate the given point and the theta is dependent on the origin being its central angle. Okay, the first thing that we could do here is to plot our point 5, -1, 1, 2, 3, 4, 5, considering that each grid here is 1 and -1 here. This is our point 5 and then -1. And we are going to determine its image as we rotate or come up with a rotation of 30 degrees about the origin. Now, the idea here is very important because the initial side, okay, this is not similar to the reflection of a point at an angle because the initial side here is no longer the positive x-axis, but the initial point is actually a line containing the point. So that would mean the original the initial side is something like this. Okay, that's the initial side, and if we're going to place arrowhead, something like that. And later on, we are going to rotate this point 30 degrees. So we are going to do it counterclockwise, right? So it will be something like this here. We're going to rotate that 30 degrees. And if we reach a certain 30 degrees, that terminal side should contain, so for example, this is 30 degrees. I'm just assuming it's 30. I'm not sure if it is. We'll be verifying that later as well. The terminal side must contain its image. And that's the item we're going to solve later. We actually have the formula for this. The rotation of a certain point under a theta is actually identified as the product of two matrices. We have here cosine theta, sine theta, minus sine theta, positive cosine theta, times the components of your point x sub 1 or x sub 2, or in some cases x and y values. Okay, our x here has components 5 and -1, and our theta intended is 30 degrees about the origin. Take note, the point about the origin, we're going to rotate it here. In short, all the angles are central angles if we're talking about the unit circle. So let's try to determine what would be the point image of the point 5 and -1 under the given rotation. This actually, the rotation of your theta is identified as cosine of 30 degrees, sine of 30 degrees, negative sine of 30 degrees, cosine 30 degrees, times the components 5 and -1. Take note that the product of these two matrices is defined 2 by 2 times 2 by 1. We would get a 2 by 1 matrix, which is similar to that, or of course identified as a point. Let's continue with the process. Cosine 30 is actually identified as square root of 3 over 2. Sine 30 degrees is 1/2. Sine 30 degrees is still 1/2, but you have negative 1/2 here, and cosine is square root of 3 over 2 times the components of 5 and -1. Take note that if you're going to multiply that, you need to make sure that you are going to use the correct components. So you have here square root of 3/2 times 5 plus -1/2 times -1. That's for your first component. For your second component, you have 1/2 times 5 plus square root of 3 over 2 times -1, which will give us a result here. You will have 5 square root of 3 over 2. Then we have here plus 1/2. That's positive because negative times negative. And the other side, you have here 5/2 minus square root of 3 over 2. Then you can combine this into just one rational expression. You have 5 square root of 3 plus 1 all over 2. And you have here 5 minus square root of 3 all over 2. This is the image of our point 5 -1 as we rotate it under in 30 degrees about the origin. Let us find out if this is the correct point. Let's make it a point here. The rotation of your theta is a point 5 square root of 3 plus 1 all over 2 and 5 minus square root of 3 all over 2. Or in decimal notation so that we can really check it on our Cartesian plane. You may use your calculators there. 5 square root of 3 plus 1, and then you're going to divide it by 2. So we're going to have an approximation here. So this is just an approximation in 2 decimal places. Okay, so you have here 4.83 positive. As for the others, 5 minus square root of 3, and then you're going to divide it by 2, and approximately a positive 1.63. So it's on the first quadrant because both values are positive. Basically similar to this. But let's try to check if it's closer to the correct value. 4.83, 1.63. So 4.83 is somewhere before 5. Yes, and 1.63 is just somewhere here, almost half. So by the way, this is the location of its image or rotation. So basically, my graph earlier on the assumption of the location of the 30 degrees is of course not accurate. I could rewrite that into this manner. So you have here, okay, this is now the correct angle of 30 degrees, and this is now the point, its image along about the origin. Again, rotation of 30 degrees. So this is just how different it is from the previous discussion on the reflection of a point at an angle, because the initial side is always the positive x-axis, but this time the location of the point is your initial side, and the terminal side is where your image is located. Thank you very much for watching.